Before we start our presentation, I would like to introduce our group members. The first one is me. I'm Siti Shah Junaidah binti Salam. The next one is Karunisha binti Rahman. The third one, Nurul Aini Syafiqah binti Abdul Rahman. Next, Nurul Hani binti Abu. And the last one is Nur Shamilia binti Sufi.
My name is Nur Hani binti Abu. I will present the introduction of this study. From the figure on the left side, the gas formation volume vector is the total free gas phase volume at reservoir condition divided by the gas volume of the same sample at standard condition. It does not include the solution gas volume. Fortunately, in the most cases, the phase behavior of gases can be explained by equations and correlations so that we can easily calculate the gas formation volume vector with a simple formula rather than performing a back test on the gas tank. The expression is shown on the equation 1. For gas reservoir and pipeline calculations, it may be convenient to express equation 1 in unit for cubic feet per scope as shown at equation 2. The result of this study, the typical shape of the gas formation volume vector as a function of pressure, is shown on the figure on the right side. The graph shows that the formation volume vector is inversely proportional to the pressure. This makes sense because as reservoir pressure declines, the gas will expand to occupy more volume in the reservoir. As we can see, BG increase as reservoir pressure decrease. So that's all from me for the introduction. Let's move to the next part. Thank you.
Nice.
Assalamualaikum. My name is Nur Shamilia binti Sufi and I would like to talk about background of the studies. The gas formation volume factor (FVF) is a measure of the volume of gas, a reservoir pressure and temperature required to produce one standard volume of a gas at the surface. The formation volume factor reservoir decreases in a reservoir because of pressure decreases and temperature increases. This is also because of three main factors: because of composition of gas, reservoir pressure and temperature, and gas compressibility factor. Based on these three factors, the higher more gas are compacted, the more pore will be expanded. It is also applied in the Darcy law, such as imperial equation and numerical simulation method. In these studies, we will conduct simulation on gas formation volume factor on each pressure. As you can see, we have height 30 feet, width is 50 feet, permeability is 50 Darcy, viscosity is 2 cp, P initial 2100 psi, Q is 4, T is 623.67 Kelvin, and also from formula, it also have formula for area, find the pressure, and also BG. Next, when we calculated, we have tabulated the data on the table. The table shows the length, pressure, and Z on every different type of length. First, the length must be converted from meter to the feet so that we can get on the field unit. After that, we will construct the graph gas formation volume factor, which is BG against pressure. The higher pressure, the lower BG. So we get nonlinear graph. Based on the theory on the reservoir engineering, it stated that the more higher compacted gas increases, the more decreases of the pore at the more aspect of the pore. It is justified by this graph.
Hi, Assalamualaikum. So my name is Nurul Aini Shafika and I will be explaining each line of the command in the script file. First and foremost, we will be commenting and explaining the purpose and approach of the MATLAB script, and by using the percentage symbol, it will not be displayed in the command window. And then I will define all the variables that will represent the information required, and I will use the asterisk for multiplication and semicolon so that it will not be appeared in the command window when the code is run. After that, I will be converting the temperature from degree Fahrenheit to degrees Fahrenheit by adding the value of Fahrenheit. Then I will be converting the length data from meter to feet using the variable n that represent the column vector of length value in meter, and reshaping the L to 3 times 3 matrix, and each element will be multiplied with 3.28 to convert meter to feet, resulting in matrix L. And then I will command whos to display all the variable, and I will calculate the pressure using the Darcy law equation. And then after that, I will define a matrix set that represents compressibility term data, which element in the matrix correspond for the FEF. And then I will calculate the FEF with the compressibility term Z, P, and T, and it will represent SPG. Then I will fprint F and create table T using the table function, and then convert to a column vector using the symbol P double dot and BG, and the column name are specified as pressure FF, and it will be displayed as display T. Then I will be sorting the P and BG by using the sort function and rearrange accordingly. Then I will create a table, and that will include the sorted pressure FF, compressibility term Z, L, and the table column are named as pressure FF, compressibility term, and depth, and it will be displayed as display N. After that, I will be reshaping the matrix P, and I will reshape the function. I will using the reshape function that convert P from a 3 times 3 matrix to a 1 times 9 row vector. The sort function is also been used, and I will be format short G for the P and BG. However, for BG, I will use the descent option, and the value will be in descending order. Then I will fprint the FEF versus pressure plot, and for the relationship between FF and pressure. Then I will be plotting the function using the P on the x-axis and BG on the y-axis using the plot style, which is set to R, which is red, and display the dash line with red asterisk marker, line width, marker face color, and also marker size properties define the appearance of the line and markers. Then I will be labeling the pressure on the X and FF on the Y, and set the title for the relationship between gas and FF. Then I will add a legend which label the FF, and I will turn on the grid, and I will save them to PNG, and then I will check if the value BG is greater than the threshold value, which is threshold FEF. The any function return the true if any element of the logical array BG is bigger than threshold FEF is true. If the at least one FEF is greater than the threshold, it will display the message stated, and otherwise it will display the message all FF value are less than equal to the threshold. Then I will define a depth index with the minimum and maximum pressure using the mean pressure and max pressure, and check if the pressure value at the specified depth using the P depth index is within the range. The result will store in the logical variable, which is the is pressure in range. Then the line will display message based on the minimum and maximum pressure, and use the fprintf to format and display the pressure. After that, I will use the average FEF by taking the mean value of the PG, and use fprintf also to display the value with 4 decimal places. And then I will calculate the standard deviation value BG, and the std function is used to compute the standard deviation, and use the fprintf to also display the standard deviation of the FEF with 4 decimal places. Then I will use to calculate cumulative of FEF by using the def using the CumSum function on the BG, then use for loop to iterate over each element of the def-L and display the cumulative FEF using the fprintf. Then, the total gas volume in the reservoir is calculated by summing the FEF values stored in BG and multiply the gas production rate Q and converted to SCF. The gas saturation at each depth is also determined by dividing the total gas volume by the product of reservoir area and height. The average permeability across all depth is calculated using the mean function of the permeability vector. The pressure corresponds to the highest and lowest FEF value and is found using the max function on BG and corresponding pressure value from P. The pressure difference between the highest and lowest FEF is also computed. The slope of FEF versus pressure curve is determined by dividing the difference in FEF by the pressure difference. The direction of FEF versus pressure relationship, increasing, decreasing, or constant, is determined based on the slope value. The rate change of the FEF with respect to pressure is calculated using the different function on BG and P and then taking the mean of the resulting value. And lastly, a thank you message is displayed. This command provides insight into the gas volume, gas saturation, permeability, and also the FEF versus pressure relationship and the rate change of FEF. Before running, I will check if there is any error, so when I run the code, there will not be any error. And here I seems to have an error and I will be checking them, but I could not find, so I will just delete it, so that I will run my code smoothly and then save my file to a format of, for the graph I will save it into a figure type of file, and for the MATLAB script I will be saving it into the M file.
Next, we move to our discussion. So firstly, MATLAB is a versatile software that can be used to solve a variety of problems in the oil and gas industry, including the calculation of gas formation volume factor at different reservoir pressure. Gas formation volume factor is the ratio of gas volume under reservoir condition to the gas volume at standard temperature pressure to estimate the amount of gas that can be produced from a reservoir. It is given the symbol Vg and is often expressed in either cubic feet of reservoir volume per standard cubic foot of gas or barrels of reservoir volume per standard cubic foot of gas. MATLAB can be used to calculate gas formation volume factor using a variety of methods. One common method is to input the gas pressure, temperature, gas compressibility factor into the formula. In addition, to calculate gas formation volume factor, MATLAB can also be used to plot graph gas formation volume factor versus pressure as the question asks. As pressure decreases, the gas sharply expands due to its high compressibility, thus the gas formation volume factor increases as well. There are many benefits of using MATLAB as it is a versatile software that can be used to solve a variety of problems in the oil and gas industry. Another benefit is can be used to calculate gas formation volume factor accurately and easily. User-friendly software that is easy to learn and use. And lastly, cost-effective software that is available at the fraction of cost of other software solutions.
Oh my god! Wow!
Hi, I'm Siti Shahjunada. I will explain the conclusion. In conclusion, this programming script shows how to solve Darcy law equation where they evaluate output reservoir pressure at different depths, and from the output obtained, it is then used to find gas formation volume factor for every gas pressure. In this study, the gas formation volume factor was investigated at different reservoir pressure using MATLAB software. The results show that the pressure is inversely proportional to formation volume factor. This is because as the reservoir pressure increases, the gas molecules are forced to close together, which make it more difficult for them to escape from the reservoir. Therefore, the result of this study can be used to improve the accuracy of reservoir models and to help engineers make better decisions about how to develop and produce gas reservoir. With that, I thank you.
Hi, Assalamualaikum. Back with me, Nur Aini Shafika. I will be adding more information that will support our main ideas and key finding with more completed information and present a more complete explanation of the recent topic upon the script file. Alright. So let's start with what our result after we have run the code. So first and foremost, our temperature has been converted from Fahrenheit to Rankine, which is the 623.67 Rankine. However, for our length data from meters to feet, as you can see, it is in a vector column, which is a 9 times 1 matrices. We will reshape and convert them from meter to feet and reshape into 3 times 3 feet matrices, so that when we will construct a table, it will have all the same size. And after we have completed the whos command, it will display all the variable in memory. And when the Darcy law equation have been substituted for the required information in pressure, which is the length in feet, it will display all the results in 3 times 3 matrices size. And compressibility term data is also in 3 times 3 array matrices. And for the formation volume factor, it will display the result by substituting the data required in the BG equation, which is the ZT and also the output pressure that have been calculated earlier. And here are the display table that we have command. We have put the column label as pressure, PSIA, FPF, compressibility terms, and also depth in feet. And also, after that, we will reshape back the P and BG term into the 1 times 9 array matrices for plotting the graph. But we will also sort the P into ascending order and BG in descending order to satisfy our hypothesis. And this is our computed graph, and the threshold FVF value is 0.02, and it is logical. All FVF value are less than or equal to the threshold. Depth index is 5, minimum pressure is 1,800, maximum pressure is 2,000, and the pressure in range is logical. And also the pressure at depth is outside the range of the minimum and maximum pressure. So for our programming script, as I have mentioned earlier on, it will calculate the FVF and also the incompressible fluid flow through linear porous media with using the variable that we have been providing. However, what I want to highlight here is the script will check the threshold value here. If it exceeds the FVF, and it will display the appropriate message with using the if-else function and end so that it will run smoothly. And also, it also checks pressure at specific depth within range and provide a corresponding message, which also use the if and else. After that, this script will analyze the relationship between the FVF and pressure by finding the pressure corresponds to the highest and lowest FVF, and the pressure differences between the extreme FVF and value of the slope of the graph are also determined. And also, it will determine that the FVF is whether increase, decrease, or remain constant with the increasing pressure. The rate of change of the FVF with respect to the pressure calculated, and the average rate change is also displayed. And finally, this script will conclude a final message with a thank you message, as you can see here. I'm sorry for pointing out the wrong direction. And finally, as you can see, this is the result with the plotted command data. For our graph, we want to have a solid line color green with the marker type as the dash dot print, arteries, line width of 5, marker phase color of B, marker size of 15. As you can see here is the line width. Here is the marker phase color, and lastly, here is the marker size of 15 in point. All in all, our MATLAB script presented and focused on reservoir engineering specifically determine the formation volume factor in incompressible fluid flow through porous media. Our script will cover various calculations such as temperature and length condition, sorting and displaying data, analyzing the relationship, and will provide insights into the average, standard deviation, cumulative, total gas volume, gas saturation, and also average permeability. Thank you so much for your attention during this presentation. We hope that you enjoy our presentation, and we hope that we have provided you with a great and useful information. Assalamualaikum warahmatullahi wabarakatuh, and goodbye everyone.